Okay guys, welcome back to our video, right? And today I got a question from my student here regarding this differentiation of exponential functions. Okay, the question is about the curve C has an equation of this: y equal to 3e to the power of x plus a squared x minus 2a, where a is a constant, and we are required to find the, in terms of a, the gradient of the tangent to your curve C at a point P where x equal to 0. Okay, so let's copy this equation that we have to differentiate. Alright, put it nicely here. Okay, so let's go going. So your differentiation, find in terms of a the gradient of the tangent, right? So the gradient of the tangent, obviously the differentiation of your curve, right? So that will give you your, so your dy dx will be 3e to the power of x, right, plus your a squared, right, because this one a squared x is to the power of 1, so differentiate, so x is gone. And at point P, right, when x equal to 0, okay, so your gradient, right, the gradient of the tangent to P, right, at P will be substitute, right, so your dy dx at P will be 3e to the power of 0 plus a squared, because x equal to 0, you just substitute in, right, that will give you 3 plus a squared. This is the equation of the tangent, the gradient of the tangent at P when x equals 0, right? Just to recall, okay, for those of you still not sure about how to differentiate exponential term, okay, so imagine you have your general formula here is ke to the power of fx, okay, right, you differentiate that with respect to x. You just copy exactly the same thing, ke to the power of fx, and then you're going to multiply that with your derivative of your fx. That's all. Simple. You don't have to memorize other ridiculous formulas, right? Just use this general formula will do. Okay, let's go to part 2, right? It is slightly more challenging. Alright, the tangent to C, means to the curve C at P, passes through the point K6. Alright, and for the case K equal to 1, right, find the values of A. Alright, so again we use this equation, that the curve, right, y equal to 3e to the power of x plus a squared x minus 2a at point P, right, passes through this point. Okay, the exponential curve looks something like this. Okay, let's just draw for you so at least you can visualize what we are doing. Alright, because if you can visualize it, you're able to solve it better. Alright, it's not a straight line, it's a curve, right? Slightly curve. Okay, okay, that's nice. Okay, so what we have, this is the curve C, alright, this is the equation. Okay, and we have a tangent at P. Okay, this is your point P. Okay, because P is when x equals to 0, right? Okay, this is your x-axis, this is your y-axis, this is just a curve, just a sketch, and this is your tangent that passes to point K6. Okay, this is another point. Alright, just make it red so you can see better. Okay, so these 2 points, the red points, are the points that we are interested in. Okay, because we are going to find the tangent to C, to the curve C, that passes through the point K6, right? K6. Okay, and for the case of k equal to 1, we are required to find the values of A. Okay, so at point P, at P what happened? At P x equal to 0, isn't it so? So we're going to substitute into the equation here. So y equal to 3e to the power of 0 plus a squared 0, okay, minus 2a. Alright, so that will give us 3e to the power of 0 is 1 minus 2a. Alright, that's all about it. Okay, so point P is 0, 3 minus 2a. Okay, that's the coordinate of point P. And we already have the coordinate of point P, and we have the other coordinate that the point P passes through the point K6, correct or not? So we use these 2 points, right? And also we know the gradient, isn't it so? The gradient of the tangent is, just now we already found the dy dx is your dy dx to the tangent at point P is 3 plus a squared, right? Therefore we're going to use your y minus y1, x minus x1, the formula, right, equal to your m, the general formula for your straight line graph, right? Okay, so what will happen is the y minus y1, which is 3 minus 2a, over x minus x1, which is 0, equal to your m, gradient is 3 plus a squared, right, at the point when x equal to 0, right? So we simplify this equation, we get y equal to 3 plus a squared, right? Let me just put the square nicely, right? Okay, multiply by x, right? You bring over, so you multiply by x plus there, this negative, so you bring over, become plus 3 minus 2a, right? Okay, so when k equal to 1, right, so we're using the point, we're using 1, 6, correct? We're using this point, and we're going to substitute into this equation, right? Equation of the tangent, alright? So the equation of the tangent is this one, right? Okay, so we're going to substitute that. So what happened? Your y is 6 equal to 3 plus a squared. Your x is 1, okay, you multiply by 1, plus your 3 minus 2a. Okay, therefore this one will be 6, 3 plus a squared minus 3 minus, plus 3 minus 2a, right? After that, what happened? So the 6 bring over there, alright? So what we have is a squared minus 2a, right, equal to 0. Why? Because 3 and 3 is 6 and 6 gone, alright? So we have a bracket a minus 2 equal to 0. So the two possible values of a will be, it means a, therefore a equal to 0 or a equal to positive 2. Okay, I've drawn the curve of 3e to the power of x plus a squared x minus 2a, alright, using a graphical calculator. Alright, so the green one, yeah, the green one, what happened is that the green one, when a equal to 0, okay, so when a equal to 0, your point P, yeah, will be 0, 3 minus 2a, right? That means your point P will be having a coordinate of 0, a equals 0, so substitute inside here. So that means 0, 3. So exactly you can see that from the graphical calculator proven that this is the point. You can see 0, 3. Right, this is your point P, and the one that it will touches is 1, 6, isn't it so? Right? The gradient touches 1, 6. That's a point, and we're going to draw the straight line here. Okay, let me just expand this so you can see clearly how to get the gradient, right? How the gradient is drawn. Okay, alright, done. So what we have is we can see, okay, the gradient that we know is your dy dx just now, right? Your dy dx, okay, is equal to your dy dx gradient to your point P is 3 plus 2a. 3 plus a squared at x equal to 0, right? Okay, so that will be what? Your a is 0, so your gradient is 3. Your gradient is 3. So let's try, is it really 3 or not? Alright, so we have 6 here, we bring down, okay, we bring down to here, okay, so that it will be the gradient. This is 6 unit here, and here is 1, this is negative 1, so there are 2 units here. Alright, so 6 divided by 2, is 3. The gradient is indeed 3. This just for you to visualize what's going on. Okay, let's try the blue one. Right? I just want to show you, just for fun of it. Sorry, just push it away, put it back here. Okay, I just want to show you when what happened when a equal to positive 2, right? For the blue line. Yeah? So when a equal to 2, oops, let me just use blue, just to differentiate it. So when a equal to 2, okay, what happened is that remember your point P is 0, 3 minus 2a, right? And from there we have P 0, 3 minus 2a, 2 times 2 is 4, right? So 3 minus 4 is negative 1. So that is your point. You can see? Let me just zoom in, right? This is a negative 1 there. Okay, there's a negative 1 here, and you're going to touch the point 1, 6, correct? So we're going to draw this line here, right? Touches here. Alright, so we check this one be bring down, go all the way down here. So 6, and then this is negative 1, so total 7 unit. This is positive 1 here, right? So again this is 1 unit, so 7 unit divided by 1 is, that means your dy dx is equal to 7. Let's try to prove that. Okay, you know that dy dx, dy dx, we can even use the equation here, is it? We can even use this equation, right? So your dy dx here is equal to when x equal to 0, right? So that means it will be 3. If we differentiate here, will be when a equal to 2, yeah, sorry. Alright, when a equal to 2, your dy dx is 3e above x plus a squared. Alright, so your a squared will be a is 2, so is 3 plus 4, which is 7. Alright, so your dy dx is still, by calculation, is 7. By graphical method is also 7. So we are correct. Alright, this just to prove to you by graphical method, right? By calculation we have done it, right? And okay, that's your part 2. Okay, let's go to part 3, right? Let's say part 3. Part 3 is what happened is that we are required to show that the maximum possible value that k can take is 3 plus square root of 21 over 6. And after that we are required to find the exact minimum possible value that k can take. Alright, let's do this. Okay, at point P, we know that at point P, right, which is your coordinate of 0, 3 minus 2a, right? And let me just sketch the graph again. Okay, just a rough idea to have some visual, right? Okay, the graph is something like this. It's a curve, right? Okay, all right. So what will happen is that if this is your point P, okay, which is 0, 3 minus 2a, using the equation of the tangent, so we draw the tangent here, right? Just a tangent. Oh, doesn't go straight. We try to draw again a straight line. Okay, nice straight line there. Okay, so that is your tangent. Yeah, this is your curve, this is your tangent. So using the equation of the tangent, which is we already got it just now, equal to 3 y equal to 3 plus a squared x, a squared times x plus 3 minus 2a. Okay, as you know, it's a straight line graph, isn't it? This is your gradient m, right? And this 3 minus 2a is your y-intercept, right? Given that the tangent to curve C at P passes through the point K6, right? So imagine this is your K6, alright, your point K6 here. Okay, passes through the point K6. Okay, we're going to substitute the K, 6 into the equation of the tangent. Okay, we use the k comma 6, right? We use this coordinate to substitute to the tangent or to the equation of the tangent. Alright, so 6 is your your c, your y, sorry, your y 6 equal to your 3 plus a squared k. Alright, because why k? Because x is k, isn't it? Substitute in, yeah, this coordinate, right? Okay, so that's your k minus or plus 3 minus 2a. Okay, and from there we have open up the bracket, so we have 3k plus a squared k plus 3 minus 2a, right? We further simplify to bring out the 6 over to the right, so what we have is ka squared minus 2a, right, plus 3k minus 3, right, because this one 6 bring over minus 6 plus 3 give you minus 3 equal to 0, right? Okay, so we have a quadratic equation again, right, in a different form where k is constant, right, where k is constant and your a is your variable. Okay, in this case a is your variable, k is constant. Alright, and since a is real, right, your discriminant for your this quadratic curve, right, that means your b squared minus 4ac is greater than or equal to 0. Your b squared minus 4ac is greater than or equal to 0. Therefore, we use this, right? So your b squared minus 2, isn't it? So this is your b minus 2 bracket squared minus 4ac. A is k. Your c is your constant term is 3k minus 3, right? Greater than or equal to 0. Okay? And what we have is 4 minus 4k times 3k is 12k squared, right, plus 12k, negative and negative give you positive, 4 times 3 12, right, 12k, don't forget the k here, greater than or equal to 0, right? And then after that we can always simplify further, so 1 minus, divide everything by 4, so 1 minus 3k squared plus 3k greater than or equal to 0. Alright, and now we have to make sure that the k squared is positive, so we have 3k squared, right, minus 3k minus 1, then we have to change the inequality symbol, become less than or equal to 0. Okay, I will explain this in terms of graphical method. Yeah, I will explain in greater detail later. So from what we have here, we can consider, let's say we have to consider, right, consider that 3k squared minus 3k minus 1 equal to 0. So your k equal to, using your formula, right, remember your formula, what is the formula? So remember your x equal to the formula of your quadratic, the minus b plus minus square root of b squared minus 4ac over 2a, right? We use this to find the roots, right? So k equal to minus bracket minus 3, right, plus minus square root of b squared, that is your negative 3, right, negative 3 here, so negative 3 bracket squared minus 4, a is your 3, c is negative 1. Okay, expand further, so 2a, 2 times 3, right, that will give us positive 3 plus minus square root of negative 3 bracket squared, so it gives you 3 squared, which is 9, minus is plus 12, right? Okay, so it is 21 positive, right? Negative 3 bracket squared is 9 plus, right, plus 12, 21 over 2 times 3 6. That's it. So from here, what we have, this is where I want to show you, right, from this graph, by graphically draw this y equal to 3k squared minus 3 minus 1, right? These are the two values, right? The positive value is your 3 plus square root of 21 over 6. The negative value is your 3 minus square root of 21 over 6. Now we know from our equation here, right, it is this graph 3k squared minus 3k minus 1 is less than or equal to 0. That means for the value of y less than or equal to 0, that means your k axis, this is your k axis by the way, right, will be the wanted region is all here. Okay, all here. This is your two possible values of k. Okay, so since this is the one, so it has to be going this way, correct? Since these are the wanted region, these are the wanted coordinates, correct? Okay, I will try to make a video of this specifically for the quadratic equation involving inequalities, right? Because a lot of students still confused. Okay, so from here we know that the maximum and minimum values, right, of k, okay, has to be, k must be less than or equal to this value, right? 3 plus square root of 21 over 6 must be less than that. Okay, it has to go to the left of this portion, right? Okay, and must be greater than or equal to the lowest point, right? 3 minus square root of 21 over 6. That means the maximum value of k will be equal to 3 plus square root of 21 over 6, and then the minimum value of k is equal to 3 minus square root of 21 over 6. Okay, this is shown. We are required to show this, right? Shown already. Well done. And the minimum also we have found. We found the value. Simple. So this question is very interesting because it involves a lot of knowledge that you have learned before, and you have to combine then everything into one beautiful questions. Yeah, so that's all about it. We have solved everything, all three parts of the questions. Thank you for watching. Have a nice day. Thank you. Take care. Bye bye.